Okay, so now we can start with the next concept which we have to discuss. Let us do that. Generalization of Cauchy's integral formula. So the Cauchy's integral formula which we discussed, now we will be looking at a general property, like a general formula of it. That we are calling the generalization of Cauchy's integral formula. Generalization of Cauchy's integral formula. So the formula, general formula is something like this. Differentiating the function n times n factorial upon 2 pi I. Integration of f of z, z minus a to the power of n plus. Dz. So this is a general formula. And now we will look at how to use this formula to find some more different types of integrations. Like to solve some more different types of integrations, wherein in the denominator, z minus a can have higher powers. If in the denominator z minus a is having a normal 1 power, then so we can use the formula which we discussed earlier. But for higher powers, we can use this Cauchy's generalization formula. Now let us see how we can do it. Let us look at one question. So we have to find the integration of z plus 1 upon z minus 1, z minus 3. Dz. Also, here C is mod of z is equal to 2. So in this question, basically the contour, its equation is given. So the equation of the contour is mod of z is equal to 2, and we have to find this integration. So definitely in solving such questions, first we have to visualize the contour, and based on that we have to solve. So looking at the equation of the contour, we can see that it is a straight, it's a circle with the center in the origin and the radius 2. So let us draw a circle.
तो ऐसी फिगर कितनी बनानी पड़ती है
Yeah,
एग्जाम में आधा टाइम तो इसी में चला जाएगा
yeah, yeah. You have to like visualize the contour. It's important.
तो बनाना ही बनाना है
Like you can make a rough diagram. Like it will not take that much time. You can make a very rough diagram. It's fine. The idea is to just to show the region. We have to visualize the contour, and then we will say that okay, this integration we are doing for this contour. So here, this is the center, and since the radius is 2, this point will be plus 2, this point will be minus 2. And this is important because we will be able to identify, we will be able to simplify this function. How? Let us see that. Now, here we have to analyze at z is equal to 1 and z is equal to 3. At z is equal to 1 and at z is equal to 3. At z is equal to 1, since that 1 lies within this circle, integration is possible. Because at z is equal to 1, it is inside the circle. So integration is possible, like we have to consider this point. But z is equal to 3, you can see that it is outside. This is outside the circle, this point. And since this point is outside the circle, what you can say?
integration is not possible zero is there
Integration is not possible. So the integration 1 upon z minus 3 dz will be 0.
z upon z minus 3 is equal to 0
So the final integration which we have to calculate z plus 1 upon z minus 1 z minus 3 dz. It will be equal to integration z plus upon z minus
z minus 1
dz. and it is like z minus 1 to the power of 1. So we can use this formula.
So,
Yeah, I am bringing this formula. Like we can refer to this formula to solve this. So this I can write, it will be equal to 2 pi I into f of a. Like here a is 1, so 2 pi I f of 1.
तो लेकिन यहाँ पे हमारे n वो भी तो होता है ना, n फैक्टोरियल।
नहीं नहीं, that is
हम जनरलाइजेशन वाला यूज नहीं कर रहे हैं इसमें।
for higher powers ना, n plus 1. अगर denominator, if the denominator has higher power, then we have to use that. But here the denominator is just 1. Like you see here.
So
This
how
is,
we are writing directly that it's 2 pi n?
I am telling. Let me write it. I will explain why. So, see, the idea is that this integration, what this integration will be 2 pi I into f of a. So this integration is similar to this integration, like the same form it is. Here f of z is z plus 1 and z minus a is z minus 1. So 2 pi I into f of 1 and f of 1, what it will be, we will see that.
So why it will be f of 1? Because it's f of a equal to f of a, that's why.
Yeah. So see, we have to compare this with this. So this we are calculating, and what it will be 2 pi I into f of a. 2 pi I will take it here, then that side. So this integration will be 2 pi I into f of a or f of a into 2 pi I. Whatever you want to say, you can say. That's great. So we have to multiply it with f of 1. Because here a is 1. Why a is 1? Because what is a? Z minus in the denominator. So here z minus 1, so z minus a. So a,
So it will be 2 pi I only, no?
yeah, 2 pi I into f of 1.
So this will be the final answer.
No, one more step we have. So here a is equal to 1 and f of z is equal to z plus. So f of 1 will be 2. F of 1 will be the final answer will be 4 pi I.
4 pi n.
Because f of 2 is 2, so 24. This is how it is. Isn't it?
Yes, sir.
Now we will look at one more question that will include the Cauchy's general formula. integral for the function e to the power of 2z upon z minus 1 cube dz.
Sir, I think in second question we have done something wrong.
Why? No, there is a typo that we will discuss later on. End of the class, I will
In the
discuss.
question, in the PDF.
Yeah, in the PDF, in the solution, there is a typo that we will discuss. Today itself, we will do like end of the class.
Like there is wrong, no, not us.
Yeah, ours is right. See, just see now, we have followed the same concept. No?
Yeah.
Outside the circle, this. So it will be this. Z plus 1 upon
Ours
Z.
is correct only.
Yeah, so it is resembling with this f of z. So C is mod of z is equal to. Okay. So now first let us visualize this. So definitely once again we have a circle with the center at the origin and radius 2. Isn't it?
Yes, sir. Two and minus two.
And definitely here we are interested only like the point is z is equal to 1. And since that point is inside this circle, we have to
The integral is defined.
yeah, integral is defined. Integral is now see. Now since in the denominator I have a higher power. In the denominator the power of z minus 1 is 3. So definitely the generalization of Cauchy's formula, that is what I have to use. Let me copy this. Like we have to use this. How to use this? That is what we are seeing. Now see, the integral which I have to find, let me write that. The integral which I have to find, that is integral of c e to the power of z, like e to the power of 2z upon z minus 1 to the power of 3 dz.
Yes, sir.
It will be equal to. Now, before that, let us do mapping f of z according to the formula, and the function we have f of z is e to the power of 2z. A is 1 and n is 2.
A is 1.
Yeah, because z in the denominator we have z
Okay,
minus 1.
yeah.
And the power is 3, so power is n plus 1. So n plus 1 is 3, so n is 2. Now, according to this formula, this integration will be 2 pi I upon n factorial. So 2,
But n will be 3, no?
no, n plus 1 is there no, in the formula. See? N plus 1 is 3. So n will be 2 now.
Okay.
In the formula n plus 1 is there. So 2 pi I upon n factorial. So 2 factorial into f. I have to do the derivative of it 2 times. And a is 1. So this now I have to find. It implies that f of f dash z, fz I know. So f dash z I can know 2 e to the power of 2z.
2e to the power 2z.
It implies a double dash I can calculate 4 e to the power of 2z. And f double dash 1 will be 4 e square. 4 e square. That I can substitute here. 2 will cancel. The final answer I will get is 4 e square
So
pi
z
I.
will keep as 1.
Yeah. See here, FA now, FA. So f of A here formula. What is A? A is 1. So f of 1 we have to calculate. See what we have to calculate. We have to calculate the double derivative of the function at the point 1. So the double derivative of the function at point z we calculated. Now we will be calculating at point 1. So z will become 1. Now see what it will. 2 will cancel. So 4 pi I e square.
So how?
Just try. See, instead of f double derivative I can write 4e square. So here I can plug 4e square. And this 2 will cancel.
And the 2 is cancelled.
Yeah.
Okay.
Isn't it?
Yes, sir.
So this is how it is. One more question. See, in this question, we have to evaluate z cube e minus 1 upon z minus 1 cube dz. This is what we have to evaluate. And here C is mod of z minus 1 is equal to 1 by 2. So the contour equation is given. You can visualize it. So mod of z minus 1 is equal to half. It means we have a circle with the center at 1 and half as the radius. Once again, let me power this. Okay, so center is 1. So I have to shift. Just shift. Radius is half. So center is 1. So it is 1.5 and it is 0.5. So from 0.5 to 1.5, the region of the circle is defined, and accordingly we can analyze it. And don't forget to write the plane like this: the real, the imaginary. This is the origin. Now at 1, so definitely at point 1 integral is possible,
Yes, sir.
and since in the denominator we have a higher power, like z
You have
minus
to
1
use
to
a
the power of,
generalization one.
we have to use the general. So let us get that formula, because this formula you have to memorize it and you have to write it. Then only you will
Yes,
be
sir.
able to correlate it. Otherwise, it will be difficult. So let us write this formula. Now, very easily we can correlate. So ultimately, the thing which we have to find, z minus 1,
So again, in this A will be 1 only,
a will be.
and 2, N will be 2.
Here, f of z,
It will be Z square into EZ minus Z
z cube, z cube,
into
it,
E
it,
to the power minus Z.
a will be 1.
And N will be 2.
N will be 2, that is right. So according to the formula, it has to be 2 pi I upon 2 factorial multiplied by f of double derivative 1.
सर मैं ये नहीं समझ पा रही हूँ वो डबल डेरिवेटिव कैसे लगा रहे हैं n की लेके n को लेके
Yeah, f of n a na in the formula. Wait, I will show. See, in this formula, we are using this f of n a. This f of n is the derivative of the function n times and a. So it will become derivative of the function 2 times at point 1 because n is 2 and a is 1 and 2 pi I will take it there now, multiply it with this, and n factorial I will bring it in the denominator, isn't it?
yes yes sir.
Now I can do the double derivative. So here actually product rule will
तो
be
आप use
applied.
multiplication rule ना
Yeah. So 3 z square e to the power of minus less minus of z cube e to the power of minus. And once again I have to do the derivative. So it will be
तो अगर
3 I
इनमें
can.
प्लस प्लस में भी हमको लगाना पड़ेगा
Yeah,
दोनों तरफ मल्टीप्लिकेशन में
yeah. It will, yeah, that is right. 2 z e to the power of minus z plus z square like minus z square e to the power of minus less, or I can take it minus b z square e to the power of minus z minus z cube e to the power of. Now to keep the make that thing simple, f double dash two e to the power of minus 1, so 2 by e plus or minus it minus once again 1 by e minus 3 by e.
अपॉन में कैसे आएगा ये मल्टीप्लिकेशन में चल रहा है ना
नहीं, I am substituting z is equal to 1, f double dash 1
हाँ तो सर EZ भी तो अच्छा माइनस में से नीचे
yeah plus 1 by e. 6 minus 1 minus 3 plus 1 6 minus 6 minus 3. It will become 1 by e.
तो 6 minus
3.
4
No, you try to solve it. Yeah, 6 minus 3 minus 3 plus. It's right, 1 by e. So this term will become 1 by e. So finally I can write 2 I can cancel. Pi I into 1 by E. So pi I by E will be the answer. This will be the final answer. Give it a try. Let me know when done.
So done.
Now we will discuss the next concept. Next concept is Cauchy's residue theorem. Cauchy's residue theorem. Now, what this theorem is, let us look at it. If fz is any analytic function within and on a closed contour, except at a finite number of points. So in that contour, within the contour or on the contour, except some points, in all other points, the function is analytic. And those points where the function is not analytic, that we are calling it z1, z2, zn. Then R1, R2, Rn are the residues of the function fz at z1, z2, zn respectively. Then one relation is there, and that is what we will discuss. So let me write it, then it will become very clear what I'm trying to say. What is this theorem is? So this theorem says that if f of z, the complex function, is analytic, this complex function is analytic within and on a closed contour C, except at a finite number of points. Except at a finite number of points. So if in the given problem, we have some points where the function is not analytic. And those points, let us take it like z1, z2, zn. So these are the points within the contour or on the contour where the function is not analytic. within C, within the C. And let us suppose, R1, R2, Rn are the residues. Residues we have already discussed. Any complex function, I can break it into the series, Laurent series. So two terms I will get, coefficient of A and coefficient of B, like 1 by something. So the first coefficient B is the residue, which we have already discussed earlier concepts. So R1, R2, Rn are residues of Fz. At Z1, Z2, Zn respective. Then I can say that the formula integration of f of z dz, it will be equal to 2 pi I sum of residues. Now let us look at some formulas, like some questions, to get an idea how to apply this theorem while solving an actual problem. So let us look at the question. I have to find the integral over the contour for the function 4 minus 3z upon z, z minus 1, z minus 2 dz. And here contour is basically mod of z is equal to 3 by 2. Now let us solve this problem using the residue theorem. Like first, let us visualize the contour, and looking at this, we can see that there are 3 points wherein the function is not analytic. That is 0, 1, and 2. So straight away, looking at the problem, I can say that the poles are the point at which the function is not analytic. The poles of fz are 0, 1, and 2. At point 0, 1, and 2, the function is not analytic. Now let us see if we can get rid of some of the points or not by checking what are the points they are inside the circle and what are the points which are outside the circle. So this is the real axis. This is the imaginary axis. Now see, the center of the circle is the origin itself. And the radius is 3/2. That is 1.5. So 1.5 in this direction and minus 1.5. First, let me draw the circle, then I will assign it. Now I have a circle. This point is minus 1 point. Now, if I look at it, see 0, point 0 is within the circle, point 1 is also within the circle, but point 2 is not within the outside the circle. So we can ignore the point 2. We can ignore the point. I can write since z is equal to 2 is outside the circle. We can ignore it. Isn't it?
Yes, sir.
So now we have to focus on 2 points, z is equal to 0 and z is equal to 1. Now I have to calculate the residues because if I am solving this integral via residue theorem, so I should know the residues. Here 2 residues are there. And if I get these values, just I have to add them and multiply with 2 pi I to get the answer. So let us see the residues. So residue at z is equal to 0. If you sorry, if you remember, we have already seen a formula to calculate the residue. I am straight away applying that. That is limit z
That
tending
tends to A.
yeah. So here that is 0. Z minus A fz. So Z minus 0 f of 0. Or f of z, because limit anyhow I have to put it. It will become limit z tends to 0, z into f of z, the function 4 minus 3z upon z into z minus 1 into z minus 2. Z will cancel. Now 0 0 if I put, so minus 1 minus 2, so plus 2 in the denominator and 4, it will be 2 itself. So the first residue which I will get will be the 2.
So how?
See, in this equation, see, z will cancel, and
Yes.
all other z just put 0, because limit z tends to 0. If you put 0 in the numerator, you will be left with 4. In the denominator, you will be left with minus 1 into minus 2, that is 2. So 4 by 2 is 2. Similarly, we will calculate the next residue. Residue at z is equal to 1. The same formula I will apply. Now the limit will tend towards 1. Limit z tending towards 1, z minus 1, f of z. Now here I will write limit z.
Minus 1 by 2.
No, you made, I think, the small mistake, I guess. Check it. So z minus 1 and f of z, if I will put it, it will be 4 minus 3z.
It will be minus 1.
Yeah, it will be. That is right.
Yeah, because it's 1.
Yeah. Z minus 1, z minus 1. Now this z minus 1 will cancel. And if I will put 1, so in the denominator, I will be having minus 2. And in the numerator, I will be having
Z into Z minus 2.
yeah. How minus 1 will be here?
So
See,
minus 1 because,
yeah, see z minus 1 cancel.
yeah, it will be cut.
So in
And
the
4 minus 3 will be 1 only.
1 only.
And each it will be
Acha,
minus 1.
minus. Okay, right. So minus 1 will be. Okay, nice. Now to simple. Like 2 residues we got. Now according to the residue theorem, we can get the answer. Now I can say that applying residue theorem, integral of the contour 4 minus 3z. Z minus 1, Z minus 2, dz. It will be 2 pi I sum of both the residues. So 2 minus. So answer will be 2 pi I.
Yes.
So this integration we did using the residue here. Now one more question we can do. One more question. This is the integral. Dz upon z square plus 1, z square minus 2. And here C is mod of z is equal to 3 by. Now see, in this question, how to decide which method to use? So definitely this question is not at all in the form of z minus a in the denominator. So the previous all the methods you have discussed, that will not apply. So when we get stuck in such a situation wherein we are not able to get a we can get a question in the standard form, like the denominator is not z minus a, but it is something else, then you can straight away go for the residue theorem. So first, and one more interesting thing to decide to choose for residue theorem is that in this function, if you get any point which is not analytic, then definitely residue exists, and if residue exists, then we can calculate the residue. So we have 4 poles here. F of z has 4 poles. Z is equal to I minus I, 2 and minus.
So how can we say that these are the 4 poles?
Because if you put it in the denominator, I will get 0. Like the function will become undefined, or the function will not be analytic, because I square is -1. So -1 plus 1 is 0. Minus I square will also be -1. Now, whatever contour is given to us, we will visualize the contour to see whether all the points lie within the contour, or if there are some points which are outside the contour. So center is the origin itself. So let us draw a circle. Three by two, 3 by -3. 3 by 2 is 1.5. And I is the imaginary. So in imaginary also it will be 3 by 2i, and this point will be -3 by 2. So this I and -I, this is within the circle, but 2 and -2, they are outside the circle, because the circle is from 1.5 to -1.5. So these 2 points I can ignore, 2 and -2. I can write it like this. Since z is equals to 2 and -2 are outside the circle, we can ignore it. Now we will calculate the residue at I and -I. Limit z
Z
tends
tends to I.
I, z -I, f of z. Limit z tends towards I, z -I, the function.
इससे 0 हो जाएगा ना?
No,
तो क्यों z माइनस I है यहाँ पे? तो z की जगह I रखेंगे तो 0 नहीं हो जाएगा?
you कटेगा. So z square plus I can write it like this. Z -I, z plus z square plus I can write z -I, z plus. So z -I will cancel. Z
So
square.
where we, so what we get, right?
See, what I have done is that this z square plus 1, I have written z -I, z plus I. So z minus I will cancel. So 2I and I square is minus 1. Minus 1 minus 5. So my 1 by minus 10. Yeah, minus 1 by 10. Let me write it. Similarly, I will do the for the other. Minus. Limit. It will become z plus.
So ये तो zero होगा.
No. Here
कोई
once
भी
again
zero.
in the denominator we will have z minus I z plus I.
Oh, it's fine, it's fine. Will be 1 by 10.
And z square minus 4. Now z plus I will cancel. Minus I minus 2I
Yes,
minus plus. So plus 10, plus 1 by 10. Now I can apply the residue here.
Said residue theorem will include the dz.
No, we are integrating it. Like any integration, according to the residue theorem, any integration, regardless of whatever it is always 2 pi I into sum of residues. Two pi I multiplied by sum of residues. So that is
0 हो जाएगा.
the minus 1 by 10 plus it will be 0. So this was the residue theorem. Cauchy's residue.
So,
Cauchy's residue theorem, the name of the theorem. So this topic